Good afternoon. My name is Erin Balog from the Uniformed Services University, and I'm looking forward to talking with you today about cloud computing and giving you an update on this evolving paradigm for how we use the computer. As a way to introduce things, I'll start out with a few questions you might have about cloud computing. First, I'm going to answer the question about what is cloud computing, and then talk a little bit about where we are now with cloud computing. Then what the vision is for the future of cloud computing, as well as the advantages and potential risks of cloud computing. And finally, I think it's worthwhile to think about how cloud computing impacts our interests as modeling and simulation specialists. Some definitions that I found with searching. Cloud computing can be defined as the practice of using a network of remote servers hosted on the internet to store, manage, and process data, rather than using a local server or the hard drive of your own personal computer. And it's called cloud computing because the data and applications exist on a cloud of web servers. In other words, cloud computing is the delivery of computing as a service rather than a product, whereby shared resources, software, and information are provided to computers and other devices as a utility, sort of like how you pay for the electricity in your own house. And this utility is offered over a network, and that network is typically the internet. Clouds can be classified as public, private, or hybrid, and I'll explain a little bit more about that. A private cloud is a data center that supplies hosted services to a limited number of people. A public cloud sells services to anyone on the internet. In other words, cloud computing is a way to increase capacity or add capabilities on the fly without investing in new infrastructure, training new personnel, or licensing new software. Cloud computing encompasses any subscription-based or pay-per-use service that, in real time, over the internet, extends information technology's existing capabilities. Cloud computing comes into focus only when you think about what IT always needs, a way to increase capacity or add capabilities without investing in new infrastructure, without training new personnel, or purchasing new software licenses. Are you using the cloud currently? Chances are yes. Common examples include email service providers like Hotmail, Gmail, and Yahoo. Other ones that you may be a little less familiar with, Google Drive, Apple iCloud, and Amazon Cloud Drive. Again, more familiar are probably Facebook and Instagram, where everything is stored on the cloud in the internet. And in a hybrid service that some of you may have used, an example of that is Dropbox. So, for example, Google Drive is a pure cloud computing services with all the applications and storage found online. The drive is also available on more than just desktop computers. You can use it on tablets or smartphones. In fact, all of Google's services could be considered cloud computing. Gmail, Google Calendar, Google Reader, Google Voice, and so on. Our university did start using Google Apps a couple of years ago. And now our email is associated with that, even though we're a military institution. Apple iCloud service is primarily used for online storage and synchronization of mail, contacts, calendar. iCloud also stores media files. Now the Amazon Cloud Drive is storage at the big retailers, mainly for music. Hybrid services like Dropbox say they work on the cloud because they store a synced version of your files online, but most also sync those files with local storage. Synchronization is to allow all your devices to access the same data, and that is the cornerstone of cloud computing, even if you do access the file locally. Likewise, it's considered cloud computing if you have a community of people with separate devices that need the same data synced. For collaboration projects or just within your own family. There are many cloud-based web apps which you can search for on Google by just looking for best web apps or best free web apps. So how So this slide will explain different cloud service models. The cloud client that we're most familiar with here is our web browser, whether it be Internet Explorer, Firefox, or Google Chrome. Also, a mobile app can access these web-based solutions, as well as a smaller server, which is typically known as a thin client. So in the past, business owners had to have computers and software for each employee and purchase software licenses so each worker has the tools that they need. Now they can load one application which allows workers to log into a web-based service. Local computers no longer have to do all the work of running applications. The network of computers in the cloud handles that. And the first type of service model is called software as a service, abbreviated SaaS. This type of cloud computing delivers a single application through the browser, through your Internet Explorer, to the end user or the customer using what's called a multi-tenant architecture. On the customer side, it means there's no upfront investment in servers or software licensing. On the provider side, so if you design the software with just one app to maintain, costs are low compared to conventional hosting. So you don't have to upload fixes for your end users to download. Salesforce.com is by far the best known example among enterprise applications, but SaaS is also common for human resource applications and has even worked its way up the food chain to enterprise resource planning, meaning kind of a business work model with, and one of those is called Workday. Second is platform as a service, or PaaS. This model of cloud computing delivers development environments as a service. So if you want to develop something, this is how you would do it. You build your own applications that run on the provider's infrastructure and are delivered to the end users via the internet from provider servers. These services are constrained by the vendor's design capabilities, so you don't get complete freedom, but you do get the predictability and pre-integration. Some examples include the new Google App Engine, and then part of Salesforce is called Force.com. There's also cloud-based mashup platforms such as Yahoo Pipes or Dapper.net. In addition, this web service model offers application programming interface or API and shows you rules of how to build compatible software programs so that developers can use those rules to develop their software over the internet. Such discrete business services include Google Maps, the U.S. Postal Services, and even credit card processing services. And finally, infrastructure as a service. Now, the end user, the customer, doesn't often see this end of cloud computing. Amazon.com, Sun, IBM, and others, they offer storage and virtual servers that information technology can access on demand. They mainly use utility computing for supplemental, non-mission critical needs, but this may change in the future. Other providers offer solutions that help IT create virtual data centers, such as 3Tera's AppLogic, LiquidQ. So it enables IT to virtualize a resource pool available over the network. The issue with this is that cloud-based services, the integration of all of these services is rudimentary at this point. There are several companies that have started to integrate software delivery so that it can be used more easily across different companies. So OpSource concerns itself with serving SaaS providers recently introduced this thing called an OpSource service bus, which employs in-cloud integration technology from a little startup called Boomi. Then SaaS provider Workday recently acquired KeepClear, that was trying to do business-to-business integration. But we'll talk a little bit more about the integration later. So, to summarize, the advantages for users. You only need a computer and the ability to use cloud system interface software like Internet Explorer. You can access applications and data from anywhere at any time. There's decreased hardware costs, no overhead for servers or storage devices, and theoretically, you might have less need for IT support, although that is a little less clear at this point, but that may be a real future advantage of using cloud-based services. Let's see. A central server can administer the system, and it actually monitors traffic and client demands to ensure everything runs smoothly. It follows a set of rules called protocols and uses special kind of software called middleware. Middleware allows network computers to communicate with each other. Let's see. Clients, again, can access their applications and data from anywhere and anytime. They could access the cloud computing system using any computer linked to the internet. And one thing that's interesting for us in modeling and simulation is that we deal with a lot of data. And if the cloud's computing system's backend is a grid computing system, then the client or the user could take advantage of the entire network's processing power. So, for example, if scientists and researchers work with calculations that are very complex, sometimes it would take years on the individual computers to complete them. On this grid-type computing system, the client could send the calculation to the cloud for processing. The cloud system would tap into the processing power of all available computers in the back end, significantly speeding up the calculation. So within the Department of Defense, things are moving quickly related to cloud computing. So here you can see in July 2012, a cloud computing strategy was published by the Chief Information Officer for the Department of Defense. And basically that implementing cloud computing as a means to deliver the most innovative, efficient, and secure information and IT services in support of the department's mission anywhere, anytime, on any authorized device. So the Defense Information Systems Agency was named the department's cloud server broker in 2012 and tasked with developing a cloud security model for Department of Defense, unclassified and classified missions through the secret level. Missions classified above secret are not included in this model. So then this organization underneath that program was developed called FedRAMP, and it stands for the Federal Risk and Authorization Management Program, and it's a government program to certify cloud service providers at a baseline level of security under the Federal Information Security Management Act. FedRAMP allows agencies to use or build on cloud services that have been FedRAMP certified so that each individual agency doesn't have to start from scratch in certifying each computer platform being used. So it began as a way to streamline the duplicative and time-consuming work every federal agency must perform in assessing the security risks associated with cloud computing system. The cloud infrastructure services dominate the list of FedRAMP approved services. So Microsoft Windows Azure is the only platform as a service in the FedRAMP approved service providers. And even as early as this spring, Concurrent Technologies Virtual Desktop Management Service became the first software as a service to receive FedRAMP provisional approval. officials do recognize that they need to expand the range of available services to continue attracting agency participation. And in March of this year, in 2014, Amazon Web Services won provisional authority to operate cloud computing services for the Department of Defense. And they are permitted to handle unclassified data under the DoD's cloud security model. So what are the current limitations and concerns? Right now, the clouds of services are isolated. It is hard to, the availability of cloud services does not link all cloud services, so they're somewhat still siloed. Security and privacy remain a major concern. Some people I had read in the reference info world by Noor, who stated that today cloud-based interconnections seldom in evidence. Cloud computing might be more accurately described as sky computing, with many isolated clouds of service which IT customers must plug into individually. On the other hand, as virtualization and service-oriented architecture permeate the cloud, the idea of loosely coupled services should eventually make every cloud service connectable in the cloud. Cloud computing is the hardest trend to argue with in the long term. And again, these concerns about security and privacy are major. For large companies, the idea of handing over important data to another company worries some people. Corporate executives might hesitate to take advantage of cloud computing system because they can't keep the company's information under lock and key. The counter-argument to this position is that companies offering cloud computing services live and die by their reputations. It benefits these companies to have reliable security measures in place. Otherwise, the service would lose all of its clients. Privacy is another matter. If a client can log in from any location to access data, it's possible that the client's privacy could be compromised. But there are ways to protect client privacy. One is to use usernames and passwords, and to employ an authorization format where only each user can access the data or applications relevant to his or her job. The more philosophical questions are: who owns the data? Does the user or company subscribing to the cloud computing service own the data? Does the cloud computing system, which provides the actual storage space, own it? Is it possible for a cloud computing company to deny a client access to that client's data? Several companies, law firms, and universities are debating these and other questions about the nature of cloud computing. Also, the difficult part is who controls your access to the cloud. Your internet service provider, telephone companies, and media companies. And that means that you're also putting your faith in that they will continue to provide you access 24/7. You might be able to get excellent access, but it may be very expensive. And you need to trust these companies. The Apple co-founder Steve Wozniak has decried cloud computing, stating that I think it's going to be horrendous. I think there's going to be a lot of horrible problems in the next 5 years. In part, that comes from the potential crashes. When there are problems in a company like Amazon, which provides cloud storage to big-name companies like Netflix and Pinterest, it can take out all of those services, and apparently that did occur in the summer of 2012. But Wozniak is also worried about intellectual property issues, about who owns the data that's stored online. And right now, there really isn't a central body governing the cloud storage services. There is this Institute of Electrical and Engineers, IEEE, is trying to create a cloud computing initiative that was started in 2011 to create standards for use, especially in the business center. Information about this group here, but it hasn't taken hold they describe their global initiative is to promote cloud computing, big data, and related technologies, and to provide expertise and resources to individuals and enterprises involved in cloud computing. It is an excellent resource. It offers a lot of online tutorials as well that I think you need to subscribe to. But IEE Cloud Computing provides access to a variety of resources, including professional conferences, continuing education courses, and those are the websites listed there. So for us personally in modeling and simulation, how will it affect us and how we use the cloud? I mean, I think our email use as well as our DoD presence online and even in Facebook, that is closely monitored. But I think being innovators and trying to stay ahead of the curve, we really need to think about our budgets in modeling and simulation and considering how the cloud could positively impact your budget needs in terms of IT support, storage servers, and now having a handle on the DoD policy related to cloud computing. I think it's worthwhile for us in modeling and simulation to continue to think about how we could use cloud computing to better streamline our processes, especially in data analysis. Also, we have to think about privacy for our learners. We often have a lot of videos that probably could be stored in the cloud, so we would need to really consider privacy issues. And then also security for higher stakes operations for medical licensing boards. Those are the things that I'm most familiar with. And then ultimately, can we have better infrastructure and software for analyzing learner performance related to medical simulation? So these are mostly the references that I used, as well as the ones listed on the individual slides. I enjoyed talking with you today and hope you learned something. Thanks.